Good evening, everyone. In today's class, we are going to start with the 10th chapter, that is straight lines. Straight lines comes under the topic of geometry. So before I start with the topic, I want to brush up few things which you have studied in your earlier classes. So, Cartesian coordinates. What is the Cartesian coordinate? Ordered pair, or let us start with Cartesian plane. Okay, so what is a Cartesian plane? Cartesian plane is a two-dimensional coordinate plane formed by the intersection of two perpendicular lines. The horizontal line is known as the x-axis, the vertical line is known as the y-axis, and the point where the x-axis and y-axis meet is known as the origin. All right. Cartesian coordinates. What are Cartesian coordinates? The ordered pair in Cartesian plane are called Cartesian coordinates. Cartesian coordinates are in the form of x comma y always. So if I write any two numbers, for example 2 comma 3, what does it mean? It means that it is 2 units from on your x-axis. So on your x-axis it is 1 2 here, and on your y-axis it is at the distance of 3 from the origin. So 1 2 and 3, this is the point. So if I draw a perpendicular like this, a perpendicular like this point will be 2 comma 3, right? Similarly, I can take some other point, say minus 5 comma 8. So on the x-axis I have to point towards minus 5. On the y-axis I have to point 8. This is the y-axis. So 5 6 7 8. So 8 is over here. So where is going to be our point? If I draw a perpendicular like this point is going to be minus 5 comma 8. So the Cartesian coordinates helps us to locate any point, right? Any point we can locate using the Cartesian coordinates, which are represented by x comma y. Now, any point on the x-axis. So this is important while solving the questions. So let me discuss this. Any point on x-axis can be written as x comma 0. So usually the Cartesian coordinates is x comma y, right? But any point on the x-axis can be written as x comma 0, because what do you observe? Do you observe that any point on the x-axis, the value of y is 0? So any point on the x-axis you can write as x comma 0. Similarly, any point on the y-axis, it can be written as, any idea? Yes. Yes. So x comma y, usually a Cartesian coordinates is represented by x comma y. Any point on the y-axis you can take here, 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 anywhere. What do you observe? You observe that the value of x is 0. So it will be 0 comma y. Okay. So this is very much very important. Any point on x-axis is x comma 0. Any point on y-axis is 0 comma. Now, let us move on to the next topic, quadrant. Our Cartesian coordinates can be divided into four parts. Each part is called a quadrant, and the quadrant are named anti-clockwise like this. So this is your first quadrant, second quadrant, third quadrant, and fourth quadrant respectively. Now these quadrant have a speciality or a property. What is that? Any point on the first quadrant, you can take it over here, 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 anywhere. What will be the value of x and y? X comma y, if you point any point from first quadrant, it is going to be positive. Both the values of x and y will be positive in the first quadrant. Similarly, in the second quadrant, the value of x is going to be negative and the value of y is going to be positive. So x comma y, if we have like this, minus comma plus, it is going to lie in the second quadrant. Similarly, if both are negative, x is also negative, y is also negative, then it will lie in which quadrant? The third quadrant. Similarly, plus and minus, x axis is positive, y axis is negative, it will lie in the fourth quadrant. So based on this, you can get your questions. So I'm going to repeat again. First quadrant, you will be having plus and plus. The second quadrant, you are going to be having minus and plus. The third quadrant, you are going to be having both minus. The fourth quadrant, you are going to be having x as positive and y as negative. Now, can you answer this question? These coordinates will fall in which quadrant? First one, minus 3 comma 2. So here x is negative, y is positive. Minus comma plus in which quadrant? Yes, so it is going to be in your second quadrant, right? Minus 2 comma minus 6. Yes, it is minus comma minus, so it will be in your third quadrant. You can. Next, 3 comma 9. Yes, here it is plus and plus, so it is your first. Similarly, 10 comma minus 5. Yes, so plus and minus, so this is going to be your fourth. Easy, right? Okay. Now, moving on, we have something called the distance formula. Have you studied this in your class 10th? Yes, right? Yes. What is this distance formula basically tells us? It gives us the distance between 2 points on a Cartesian coordinate if we consider one of the Cartesian point to be x1 comma y1 and another point to be x2 comma y2. Then the distance d is given by root over x2 minus x1 whole square plus y2 minus y1 whole square. We have section formula also. So if there is any point P which is dividing 2 points A and B in a ratio M and N, then the point x comma y, the point P which is given by x comma y, it will be given by a formula mx2 plus nx1 divided by m plus n comma my2 plus ny1 plus m plus n, where m and n are the ratios in which the point is dividing a and b. X1 y1 is a point of a, x2 y2 is the point of. Next, we have area of a triangle also. I think this was in your deleted portion from 10th standard, so I have included this formula also. So if we have a triangle which is given by a x1 comma y1, b x2 comma y2, c x3 comma y3, then the area of the triangle is given by half multiplied by x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. So there is a pattern, right? x1, x2, x3. Here 1, 2, 3. Here 2, 3, 1. Here 3, 1, 2. All are cyclical, right? Now, this much is enough to start solving our exercise problems. So let us start with the first problem from exercise 10.1. I'll read out the question. Draw a quadrilateral in a Cartesian plane whose vertices are minus 4 comma 5, 0 comma 7, 5 comma minus 5 and minus 4 comma minus 2. Also find its area. This is the question. So first, let us point all the vertices. So the first vertices is where it is minus 4 comma 5. So minus 4 on the x-axis and plus 5 on the y-axis. So it is going to be here. Correct? Similarly, 0, 7. 0 on the x-axis, 7 on the y-axis. So this is the another point. 5, minus 5. So 5 on the x-axis, minus 5 on the y-axis. So this is one more point. The last point is minus 4, minus 2. So minus and minus, you know that it should lie in which quadrant? It should be lying in the third quadrant, right? So minus 4 on the x-axis, y minus 2. So this is the point, right? Now I can join this. So first part of the question is done. Draw a quadrilateral. We have drawn a quadrilateral, right? Now let us name the quadrilateral, say A, B, C and D. So the first part of the question is done, right? What is the second part? Second part is find the area, right? Now, do you have any formula for area of a quadrilateral? Yes, no? No, right? We have area of a triangle, we have area of square, area of uh, rectangle, area of circle we have. Do we have area of quadrilateral? No, right? No. So what we can do here, I can do a small construction. Can I draw a perpendicular AC for the quadrilateral ABCD? Yes. Now I can tell that the area of the whole ABCD is going to be equal to. So this is what we have to find out, area of the quadrilateral. So I will be writing over here area of quadrilateral A, B, C, D. This will be equal to, can I tell it is area of the triangle ABC. So let me take this area, triangle ABC area plus say ADC area. If I add these both areas, will I be getting the area of the quadrilateral ABCD? Yes. So I can write over here that area of the quadrilateral ABCD will be equal to area of triangle ABC plus area of the triangle ABC. Sorry, so this was the other color, right? So I will use the other color. So area of the triangle ADC. So this, let me write it in yellow. So area of triangle ABC. Right? Now, how can we find the area of the triangle ABC? We have a formula, right? Yes. So I can write over here that area of triangle ABC or any area of triangle, let me write the formula first, or let me just take it from there. I have already the formula. Okay. Paste it over here. Yes. So let me take just the formula. Okay. So the area of the triangle is given by half x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. Now let us consider the first triangle, say the triangle ABC. So I can tell triangle ABC. In triangle ABC, let me consider A as x1 comma y1, B to be x2 comma y2, and C to be x3 comma y3. So my coordinates is going to be minus 5 minus 4 comma 5. Here it is going to be 0 comma 7, and here it is going to be 5 comma minus 5. Now if I substitute the same in the formula, I will be getting triangle ABC is going to be equal to, so half multiplied by x1, which is minus 4 multiplied by y1 minus y3. So 7 minus of minus 5, I will be getting plus, right? Plus 0 multiplied by minus 5 5 plus 5 multiplied by 5 minus 7, right? I think somebody has joined. Let me just check for a moment. Mhm. Yes, I guess Tejas. Good evening, Tejas. So upon solving this, I will be getting area of triangle ABC. Let me write it in the next slide. So it is going to be half multiplied by, what did we have? Half multiplied by minus 4, 7 minus of minus 5. Can I write it as 7 plus 5, which is 12? Minus 4 multiplied by 12. I need not take the second one because 0 multiplied by anything is 0. 5 multiplied by 5 minus 7 is minus 2. So I can take it is plus 5 multiplied by minus 2. Right? Now I will be getting half multiplied by, this is minus 48 minus 10. So I will be getting 58. Yes. So I will be getting over here minus 58, minus 58 divided by 2, I will be getting minus 29. This will be the area. Can area of the triangle be a negative value? No, it cannot be a negative value. So you can take it as 29 square units or unit square you can take. This is the area of triangle ABC. Next, similarly, I have to consider the area of the triangle ADC. ABC is done. ADC I have to consider. So let me take that. So in triangle ADC, A, B, and C. This is taken as x1 comma y1. This is taken as x2 comma y2. This is taken as x3 comma y3. This is your D. D is taken as x3 comma y3. Now let us write the coordinates. It is minus 4 comma 5. Here it is 5 comma minus 5, and here it is going to be minus 4 comma minus 2. Now area of your triangle ADC will be given by half multiplied by you can take minus 4 multiplied by minus 5 plus 2 plus 5 multiplied by minus 2 minus 5, and you will be having here plus of minus 4 multiplied by 5 minus of minus 5, I can write as plus 5. Upon solving, area of triangle ADC is going to be equal to half multiplied by 4. 4 multiplied by minus 5 plus 2, it is going to be minus 4 multiplied by minus 3 over here, plus 5 multiplied by minus 7, minus 4 multiplied by 10. So area of triangle ADC will be half multiplied by, this is minus 4 into minus 3, I'll be getting 12. 12 minus plus 12, here 5 into minus 7, so it is 35. 35 and minus 40, minus 40, 35, it is 75, 75, 12, it is minus 63. So minus 63 divided by 2. So this will be the area of triangle ADC. So area of triangle ADC is, should I consider minus over here? No, right? Because area cannot be in minus. So I can write 63 by 2 unit square. Now, what will be the area of quadrilateral? Area of quadrilateral ABCD will be area of triangle ABC plus area of triangle ADC. So this is going to be, how much did we get area of triangle ABC? It is 29 square units, plus here it is 63 divided by 2 square units. So if we solve this, you will be getting the area of triangle, quadrilateral ABCD, that is going to be equal to 121 divided by 2 unit square. This is going to be your final answer. Is that clear?